Hello friends, let us take this problem of triple integration now. So this integration is also called as a volume integration. Okay. As you know that the double integration that we have evaluated over a region, right? Now this triple integration we will evaluate it over a surface. Okay. Right. So this is a three-dimensional surface over which we are now integrating. So usually triple integration is denoted in this way. Triple integration over V fx y z, that is a function of three variables dx dy dz. Now here there is a procedure to evaluate the triple integration. How it works? So let me just open these three integrals. Okay, the innermost integral that we will now decide that we will always this integration we will evaluate by using the variable z. Okay, so the innermost integration is always with respect to z. So I say here this fxyz dz. Okay, and the integration limits, okay, they are like this: z equal to some function of xy on the lower side and z equal to some function of xy as an upper integral. Okay, so you have to express your limits of the inner integration as z equal to some function of xy, z equal to some function of xy. Okay, now the middle integration is with respect to dy. So this we will now finalize that inner integration with respect to z, then with respect to y. So this function will be expressed as some function of x. Okay, so y is function of x, to y is some function of x. Fine. And finally, the outer limit integration we will evaluate with respect to x. So this is a constant one. So x is equal to some a to x is equal to, right? So this we will now fix that inner integration with respect to z, then y, and then x. Okay, I'll give you an example of this. So let us take one example. Evaluate triple integration over v. Okay, uh, it is given that, yeah, the limits are already given. So let me put the limits over here. So I say evaluate triple integration 0 to under root 1 minus x square minus y square, 0 to under root 1 minus x square, and 0 to 1. Okay, dx dy dz divided by under root of 1 minus x square minus y square minus z square. Okay, so this is the integration given. Now see that the inner integration is with respect to z, right? That is what we have decided. So these limits are z equal to 0 to z equal to this. Fine. Okay. Now when I am integrating with respect to z, okay, this entire factor will be a constant for me. Okay. So what I will do is I'll say let 1 minus x square minus y square is equal to some m square. Okay, a constant. So if I put it that, now I'm not replacing any variable, so there is no change in the dz or dx dy. I'm just making the constant a single term, that is m square. So my integration will be 0 to 1, 0 to under root 1 minus x square, 0 to m. See that this is m square, so under root of m square will be m. Dx, so I'll write dz first here, upon under root of m square minus z square, and then I'll write dy and then dx. Is that fine? Okay. So now you can easily evaluate this. So what is the formula for 1 upon under root of x square minus z square? So let us put that 0 to 1, 0 to under root of 1 minus x square. Okay, and then we have this integration. It is sine inverse of z upon m. It is sine inverse of z upon m. It is running from 0 to m dy dx. Okay, so now we'll put m over here. So this is further equal to 0 to 1, 0 to under root of 1 minus x square. Now see here, if I put m, sine inverse of 1 will be pi by 2. So pi by 2 minus, when you put 0, it will be 0. Now this is dy and dx. Okay, so it's a pure constant, so I'll take it outside directly. Okay, and now in a inside integration, I am with respect to y I am evaluating. So this will be y from 0 to under root of 1 minus x square. Okay, and then dx. So this is equal to pi by 2, 0 to 1. Okay, now this is what? Under root of 1 minus x square dx. Okay, and again you know this formula. Okay, so what is this? It is equal to pi by 2, okay, into bracket. It is x by 2 under root of 1 minus x square plus 1 by 2 sine inverse of x, and it is running from 0 to 1. Right? So if I put 1 over here now, so let us solve it here. So if I put 1, what I will get is pi by 2 into bracket. See, when you put 1, this will be 0. And here it is sine inverse of 1 is pi by 2, so this will be pi by 4. Minus, when you put 0, this is 0 and this is 0. So it is pi square by 8. Right? So this integration we have evaluated. Okay, this integration we have evaluated, and it is coming as what? Pi square by 8. Okay, right? So the thing is that this is one way of evaluation of triple integration, where the limits are given to you. Okay, in that case, the innermost limit is always with respect to z, then with respect to y, and then with respect to x. Okay, here one more thing we will note, that is called as a Dirichlet's theorem. So let me put that over here. Dirichlet's theorem. This will help you in evaluation of this triple integration sometimes. Okay, so it's a very typical type of formula which we can easily use. So it says that triple integration x raised to a minus 1, y raised to b minus 1, and z raised to c minus 1, dx, dy, dz. Okay, so this is a type of integration. See that x raised to a minus 1, y raised to b minus 1, and z raised to c minus 1. Okay, dx, dy, dz, where x plus y plus z is less than 1. Okay, x plus y plus z is less than 1. Then this integration is given by gamma a into gamma b into gamma c divided by 1 plus a plus b plus. this less equal. Okay, so this theorem also helps you in finding some of the triple integrations. So see, the triple integration, it's a very typical type of structure. X to the power a minus 1, y to the power b minus 1, z to the power c minus 1. ABC are constants, dx, dy, dz, where the condition on x, y, z is that x plus y plus z should be less than or equal to 1. Okay, then this integration directly evaluated with this formula. Okay, so it is gamma a into gamma b into gamma c divided by gamma of 1 plus a plus b plus. We will see the illustration of this as well. Okay, but just note this formula. Fine.